Okay, recording a short video. This is from the worksheet called Focus-Directrix classwork. In period 3 I did the first problem but not the second. In period 8, because of the half day, I didn't do either of them. So I'm going to do this right now. It takes not so long. So here we go. Based on the new definition of the conics, if you're given a focus at the origin, a directrix at y equals negative 16/3, and eccentricity 3/5, finds the equation of the conic. Basically we just do it using the definition. So making a picture, we see that the focus is at the origin, so there we are at the origin, that's the focus, and the directrix is y equals negative 16/3, so that's like negative 5 1/3. So let's go down 2, 3, 4, 5, 6, so there is the line y equals negative 16/3. And if the eccentricity is 3/5, since the eccentricity is less than 1, that is going to be an ellipse. Alright, so what is this ellipse going to look like? Well, just like the activity from class, if the focus is here and the directrix is here, then the ellipse is going to kind of curl away sort of from the directrix. And so it's going to be something like, you know, some kind of thing like this-ish. So that's very rough, not accurate, but roughly speaking, you with me? That's kind of what the ellipse looks like. Of course, an ellipse has two foci, but what we've seen from the new definition of the ellipse is that the entire ellipse can be found by using just one focus and one directrix. And so we call this this is the focus which corresponds to this directrix. Okay, let's start. What's the one thing I know about this conic? I know that the eccentricity is 3/5. Well, what does that mean? It means that if I take an arbitrary point somewhere on the conic, let's call that arbitrary point x comma y, then it must be true that if I take the distance from that point to the focus over the distance of that point to the directrix, then that should be 3/5. So based on this picture, we can just calculate what these distances are. So this distance is root x squared plus y squared, and this distance is,
What is it? D plus y?
yeah, kind of, but actually I know what d is, right?
Oh, yeah.
So the directrix is like negative 5 1/3 below the x-axis. So it's going to be like,
Y.
yeah, I think it's like plus, right? Because
Yeah.
this little bit here, this little bit here is y, because it's like over x up y, right? And then this segment has length 16/3, and so the sum of those together will be y plus 16/3. Does that make sense? Alright, so once you understand the definition of the conic, and once you've made the picture and sort of do the geometry, then you can just state the fact. And the fact is that this arbitrary point, x comma y, if it's on the ellipse, then it must be true that the distance to the focus, which is root x squared plus y squared, over the distance to the directrix, which is y plus 16/3, equals the eccentricity, which is 3/5. And that gives you the equation, and now we just basically do some algebra. You cool? So I made this problem myself so that it works out really nicely. I think the best thing to do is to cross multiply, because then you lose all fractions. And then you guys should try this yourself. we were gonna do this in class. It takes like 5 minutes. I think the next thing to do is square both sides. Guess I'll just bring everything over to one side, or almost everything. Okay. Did I do that right? No, minus. Yeah, cool. And then, okay, so this is really like 25x squared plus 16y squared minus 6y, la la la, equals 256. And then, okay, it's all working out. That is a 9. If I add 9, I really just added 144. So I add 144. It's 400 over there, and so we're all good. And if I divide both sides by 400, that proves that this is x squared over 16 plus y minus 3 squared over 25 equals 1. All right. And now, from my experience with ellipses, is that what you got? Okay. From my experience with ellipses, I now know everything there is to know about this. All right, so let's erase this old picture because it was a little bit crappy because I wasn't really trying to be accurate. I was just drawing, kind of what it looked like. But now I think I can say exactly what it looks like because I know that this is a particular ellipse. And what properties does this ellipse have? Well, first of all, the center is at 0, 3, so that's good to know. Center 0, 3. So blum, blum, blum. And then, cool. And then the A is 5. So that means it's being stretched out vertically by a factor of 5. Okay, well that already tells me like good information because that tells me 1, 2, 3, 4, 5. So that tells me that one vertex is going to be 5, so up here at 0, 8. And the other one is going to be 5 away, so down here at 0, -2. And then I also see that B is 4. So that means that my x coordinate is being stretched out by a factor of 4. So if you go like over 4, then I'll have a point here at 4, 3, and a point here at -4, 3. And so my ellipse is, basically something looking a little bit like that. And in any ellipse, it's true that b squared plus c squared equals a squared. And so in this case, c is 3, so that's what I expect. And that's like just totally true, right? Because look, here is my focus, and it is exactly 3 away from the center. So this tells me kind of everything I need to know. There's also going to be another focus, which is going to be 3 away from the center on the other side. So that'll be here at 0, 6. And there's also going to be another directrix as well, which is like sort of like -16/3. One directrix is -16/3 away from this focus, and the other directrix is -16/3 away from the other focus. So it's like 1, 2, 3, 4, 5, and a third. Way up here, picture's getting a little messy, will be another Directrix, which I guess has like equation, like I don't even know, whatever. All right, anything else we need to say about that? Oh yeah, so but a single focus and directrix are enough to create the entire ellipse. Cool? All right, so while we're here, we might as well, so that was like for period 8. We might as well flip to the back and do the other one, which is essentially just the same thing, but the algebra is a little bit harder. And maybe you have to be a little bit more careful with stuff. So this problem, number 2, says, find the equation of the conic section with focus at 8,1. So focus 8,1, corresponding directrix, x equals 14/3, and eccentricity 3/2. Okay, so make a rough sketch first, then find an equation by choosing an arbitrary point and using the definition, etc., etc. Okay, so let's go. I will try to make a big picture here. What do I know? My focus is at 8,1, so 3, 4, 5, 6, 7, 8, 1. Okay, that is my focus. My directrix is x equals x equals 14/3, so that is whatever that is, 4 2/3. So 1, 2, 3, 4 2/3. X equals 14/3, and from this I can make a rough sketch at least of what the conic looks like. So it's going to be, since the hyperbola, since the eccentricity is, it's looking a little crappy, but whatever, it's okay. Since the eccentricity is 3/2, that means it's going to be a hyperbola. What is this hyperbola going to look like, roughly speaking? Well, as we've seen from the activity today, there's going to be one branch of the hyperbola that kind of comes out like this, and then there's going to be another branch kind of like over here or something, something maybe like that. All right, and the math will just work out, so let's do it. I will choose an arbitrary point somewhere on this hyperbola, call it x comma y, and now what I know is that the ratio, the distance to the focus over the distance to the directrix, is 3/2. Okay, and good. So I just now have to figure out, like, what are these lengths? Well, I can just use the distance formula here. This is going to be root x minus 8 squared plus y minus 1 squared. And this distance is going to be, okay, well, if that point has coordinates x, then this whole thing is x, and that's 14/3, so this is x minus 14/3, this little segment. All right, so now the one fact I know in this case is if I take the distance from an arbitrary point to the focus, it's root x minus 8 squared plus y minus 1 squared over the distance from this arbitrary point to the directrix, which is x minus 14/3, then this is 3/2. And again, I think I picked out the problems, so I wrote this problem so that everything works out nicely, and if you just do the algebra, it works out. Does this make sense? Alright, so cross multiply, 3x minus 14 equals 2. Let's do this out. And I think if you're being kind of smart about stuff, I have some x's over here, so I need to multiply out my x terms. but my y terms, I'm going to be completing the square anyway, or I've already completed the square, so like don't mess with that basically. So okay, this becomes 9x squared minus 84x 6 equals, and this is 4 times, that's x squared minus 16x plus 64. But here I'll just leave it as 4y minus 1 squared. And now I just have to just keep on going. Hopefully I do this all right. So that's 4x squared minus 64. Okay, so I think I can tell which side, well, I guess I can tell, because it's going to be an x equal. So I'm going to subtract the x's over, so that becomes 5x squared. I add 64 to both sides. And then I'll subtract the 4y minus 1 squared, and I'll subtract the 196. No, if I subtract 196, then I get like 60 over here. Let's see if I did that right. Double checking. Yeah, boom, 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 boom. Okay, so then this is 5x squared minus 4x minus 4 minus 1 squared equals 60. And here I need a 4. So I really just added 20. So I add 20 over here too. And I think this all like worked out. So I get 5x minus 2 squared minus 4 squared, 80. And if I divide through by 80, I get relatively nice, not totally integer, but x minus 2 squared over 16 minus y minus 1 squared over 20. I think that looks familiar. It's a little bit of thinking and picture making, and then a lot of algebra. Okay, let's confirm. Let's erase this rough sketch, because now I can know the real sketch. And the real sketch has us, so that is the focus at 8,1. What does this tell me? Well, from this equation, I know that the center of my hyperbola is 2, 1. Okay, so 2, 1. I know that x is being stretched out by a factor of 4, so a is 4, and b is like root 20. So yeah, 2 root 5, which is like about 4 point something. And c is 6, because a squared plus b squared equals c squared in hyperbola. So c is 6. Okay, well that checks out, because indeed this focus is 6 away from the center, so it's all looking good. Where is the vertex? Well, one vertex is 4 away, so that's going to be at 6, 1, 2, 3, 4. Vertex at 6, 1, and the other vertex will be 4 on the other side, so -2, 1. And okay, I don't feel like making my happy box and everything, but generally speaking, the hyperbola is going to look like, I guess I should do it if I'm doing it properly. Okay, happy box is going to be like the y coordinates being stretched out by a factor of like 4.4. So I guess I should go like up 4.4. So it's 1, 2, 3, 4, 5. So like this-ish. Yeah. And then down 1, something like that. All right. Kind of not trying super hard here to do a good job, but these are the asymptotes of my hyperbola. And finally, the hyperbola itself It was already pretty good. Now it's even better. It's gonna look like that. Alright, how's that look? Pretty good, I think. Cool, that's it. Bye.